Welcome back to The Explainer. Today we're going to talk about Zig, a programming language with a pretty bold ambition, to be the true successor to C. But what does that actually mean in a world already crowded with powerful languages? Let's dive in.
And right here, this one sentence, it's pretty much the key to understanding the whole thing. This is the philosophy that drives every single design decision in Zig. The goal isn't just to be fast or powerful, it's to be simple and predictable so that you can focus on your code, not the weird quirks of the language itself.
All right, so here's how we're going to break it down. We'll start with the basics of what Zig is, then dig into its super tight connection with C. After that, we'll look at performance and some power features, see what's on the roadmap, and then wrap up with a more critical look at the trade-offs.
Okay, first up, what is Zig? You know, in a world with C, C++, and the ever-present Rust, what new thing is Zig actually bringing to the table? What's its unique selling point?
So the idea isn't to just throw C out the window. Not at all. It's more about taking what makes C great, that raw performance, that low-level control, and then methodically fixing its biggest headaches. I'm talking about things like getting rid of the C preprocessor and its messy macros, and making memory management less of a minefield, all without the really steep learning curve you might find in a language like Rust.
And this brings us to one of Zig's most defining features, its connection to C. This isn't just some afterthought or a library they tacked on. No, the language was literally built from day one to play nicely with the massive C ecosystem.
So how does it pull this off? Well, the secret sauce is its native support for the C Application Binary Interface, or ABI. You can think of the ABI as the universal translator at the machine level. It means Zig code and C code speak the same binary language, so they can talk to each other directly. No slow wrappers, no complicated setup, it just works.
And they don't just say it's compatible. They give you the tools to make it happen. It's pretty cool, actually. You've got a tool that can translate C code directly into Zig for you. You can import C header files like their native Zig modules. You can even use Zig as a drop-in replacement for your C compiler, one that's smarter and better at cross-compiling. This is all designed so you can adopt Zig gradually, not force a massive, painful rewrite.
And here's a really smart part of that Zig's CC tool. By default, when you're in debug mode, it turns on something called the Undefined Behavior Sanitizer. What does that mean for you? It means it tries to make C programming safer right out of the box. It actively looks for those subtle, really dangerous bugs that traditional C compilers often just let slide, helping everyone from beginners to experts catch problems early.
All right, so we've talked philosophy. Now let's get into the good stuff, performance, and some of the really unique features that Zig brings to the table, giving developers some incredible control.
So, one of the biggest wins for Zig recently has been its self-hosted compiler backend. This is now the default for your standard x86 debug builds. And what that means is, for a lot of your daily development work, Zig doesn't even need the big, heavy LLVM toolchain anymore. And wow, just look at the difference this makes. Compiling a simple program is over 4 times faster with Zig's own backend. And it uses less memory too. I mean, that's a huge deal for your day-to-day workflow, right? That compile debug loop just got a whole lot faster. And it's not just about the big picture compiler speed. Even small, thoughtful language features can have a huge impact. Take this number, a 13% performance gain. That came from switching one part of the compiler, the tokenizer, to use a single, well-designed language feature. It shows the goal isn't just making the compiler fast, it's about giving everyone the tools they need to write really optimal code.
Okay, so beyond just pure speed, Zig has some really powerful tools. You need to match a C struct's memory layout perfectly, bit for bit. You can do that with pack structs. Working on embedded systems where every byte counts, you can create an integer of any bit width you want, like a 3-bit integer if you need it. And then there's comp time, which lets you run your Zig code at compile time. This opens up a whole world of advanced metaprogramming without any of the messy macros you get in C.
Now, it's important to remember Zig is still pre-1.0. It's a work in progress. But the team has a really ambitious roadmap, so let's check out what they've got planned for the future.
So the plan basically breaks down into 3 major stages. First, they're expanding that self-hosted compiler to work on ARM64, which is a huge step towards being totally independent from LLVM. Second, they're bringing back async await, but with a new, much simpler design that puts the developer back in control. And third, they're building powerful testing tools, like fuzzing, right into the language itself. And this idea really gets to the heart of why they're building fuzzing right into the language. The goal is to make it so easy and so natural to find those weird edge case bugs that it just becomes a standard part of how every Zig developer writes code.
Okay, but no language is perfect, right? To get the full picture, we have to talk about the critiques. And Zig's focus on simplicity, well, it comes with some pretty big trade-offs that people are talking about a lot in the developer community.
So simplicity sounds great. Who wouldn't want that? But is it always a silver bullet? Some critics argue that in its quest for simplicity, Zig gives up some of the safety and expressive power that other modern languages, especially Rust, have worked so hard to build in. So the real question is, where's the right balance?
A great example of this is error handling. In Zig, you have these simple error unions. Clean, straightforward, but here's the catch. A Zig error can't carry any extra information with it. So if you get a file not found error, that's all you get. You don't know which file wasn't found. Compare that to Rust, where the error type can wrap up extra data, like the file path. That can make a huge difference when you're trying to debug a problem.
And the conversation doesn't end with just error handling. There are other major points that experienced developers bring up. For instance, Zig doesn't have a borrow checker like Rust, so it can't guarantee at compile time that you won't have memory bugs like use after free. It also doesn't have private fields instructs or automatic resource cleanup, which puts more responsibility on you, the programmer, to manage everything correctly.
This quote, it really nails the core of the debate, doesn't it? It's this idea that Zig's simplicity is also a kind of double-edged sword. It's appealing, but it might also be reintroducing some of the classic dangers that other languages have spent years trying to design away.
And that really brings us to the fundamental question that Zig is asking the programming world. It makes a conscious trade-off. It swaps the compile time safety nets and the complexity of a language like Rust for a simpler, more direct model that puts its trust in the developer to be careful and disciplined. The question is that a bet you're willing to take? Only time will tell which approach really wins out in the long run.